Hello again from Digicool Things. This is part 3 of my experiment with using a preheater for doing some SMD reflow. In the last part I did a full teardown of my UYue 9461010 preheater. So in this episode I thought I might do the next step, which is going to be reassembling it. Adding some crimp lugs where we just had bare wires previously connected to screw terminals. And once I've reassembled it, I'll need a new power supply, because if I'm not going to use the old controller, I'll need a 5-volt power feed so that I can try connecting up a different controller. So apart from all the parts I have here from dismantling the preheater, I've grabbed some lengths of mains rated cable and also some crimp lugs. Hopefully that'll be enough to keep us going. Right, so to prepare these cables, I need some side cutters. I just got myself a new pair of Engineer NSO4 side cutters, which look very nice. Looks very well made. I thought I'd spend a little bit more and get a nice cutter which will hopefully last a little bit longer than some of my other ones. Rightio, let's just snip off the ends of these wires. Okay, find my wire stripper. Now our main switch, just take the active lead off there, because what I'm actually going to do is, you see I've just attached here a little mains terminal block. So I've fed 3 wires in from the one end of the elements into one side of that terminal block. I'm going to connect the mains active on the other side. Just going to twist these wires together because I want to add the mains connection that I'll need to go to the power module. Right, let's put him in there. Find my screwdriver. Okay, we've got a good connection there. On the neutral side, let's recover the mains neutral leads from the old controller. Put the old controller aside. Now, a neutral lead I'll need to go to the SSR, and another neutral lead to go to the power module. So let's twist these guys together and feed those into one side of the mains terminal block. Okay, they're not going anywhere. The lead that comes from the main socket I'll screw into the other side of the terminal block. All those screws are nice and hand tight. Okay, now the other side of the elements, I've already twisted those 3 wires together. So I'm going to crimp those into a spade lug. Okay, where's my crimping tool? Okay, they're not going anywhere. That's good. Right, next I might deal with the earth. So in the last video I showed that the earth wire is attached to the case through with one of the bolts that goes through to the heating element. Bring that out. And so last time this was just an open lug with the earth wire soldered to it. So what I'm going to do, I'm going to basically cut that off, get rid of that. Where's my strippers gone? Grab me strippers. Right, and I had another piece of earth wire here, so I'm going to attach this as well because I'd like to just run a separate earth wire to the power module. So although the power module's metal case will be bolted to the metal case of the preheater, I just like the idea of running a separate earth lead. Okay, now I'm going to need to strip those wires back a bit further, I think. Okay, give that a crimp. Yep, they're not going to come out. Okay, let's put him back in. Right, screwdriver. Right, so we have some earth wires. Alright, what shall I do next? I think next step will be, so I might put this back in. Let's screw that back in. Right, so we have the switch assembly back in. Let's plug the earth lug back on, and what else have we got here? Neutral lug which goes on the back of the main socket, and the active lug which goes on the other side of the main switch. Okay, so that leaves me with those two wires there to go off to the power module together with the earth, and over here I have the neutral wire to go to the SSR solid state relay. So let's get like crimped onto that. Okay, right, what's next? So let's feed all this through the hole in the side of the preheater. Right, so I found this module in my parts drawer. It's a little bit overkill, 5 volts 2 amps. Probably need amp or less. But this is what I've got. Until I can find something smaller, I'll just use this. So we need to connect up an earth, neutral and active for the mains input side. So let's just grab, what have we got here? We've got our neutral, active and earth. Those wires are twist. Just open those screws up a little bit. Start with the earth wire. It's securely mounted. And we've got our neutral wire. Just feed back through, take this around this way. And lastly, our active mains wire. Sure, I'm happy with that. Right, it's all good. Now, what I might do next is just attach a couple of output wires. I might just borrow these 2 wires off the input side of the solid state relay, because I'm going to use a couple of new wires with slightly longer with spade lugs attached. Okay, so on the output side, fold that wire over. Connect the positive. And the negative. Right. So next thing I think we'll do is give this an initial test. All these plugs are on properly. And before we do anything with the mains, let's just double check that we don't have any shorts. So if we take the earth pin, let's check we've got a good earth connection, which we do. Likewise to this case, which we do. And then I'll check we don't have any shorts to the mains active. Nope. And the mains neutral. Nope. And I'll just check the mains neutral and mains active. High resistance, that looks good. Okay, just for those of you concerned about mains wiring, I'll just note that I actually use a earth leakage detector just as added safety, but whatever works for you. Right, so I've just got this mains lead here, so I haven't switched it on PowerPoint yet, but let's just plug this in. I've currently got the main switch switched on. I'll just swap my multimeter leads over to some alligator clips, put her on volts. So I can then just clip these onto the output of the power supply, which will probably need some adjusting, depending on how good they are at factory adjusting the 5 volts. Also, just to tidy up the neutral side wires from the output of the solid state relay, I might just connect those back up. So it's basically mains neutral into one side and the other end of the elements into the other side. Okay, so all that leaves us to connect is basically we've got our 5 volt power supply, our thermocouple wires, and the input side of our solid state relay. Okay, so everybody stand clear and I'll apply power. And we have 4.9 volts. No magic smoke, so I'd say we're pretty good. Okay, so I'll turn this off at the main switch. Let's get the rest of it hooked up. Okay, so for the input side of the solid state relay, I've grabbed a couple more wires here, just slightly longer than the old ones. I'll put a crump lug on the end of each. Apologies for the colour mismatch. I need to get some more crump lugs. I'm pretty much out of stock. Right, let's just strip the other ends of the wires. Give them a twist. It's a black wire. And the red wire. And let's attach these to the input of the solid state relay. So red wire to positive. Much nicer using crimp lugs rather than bare wires. And the black wire to the negative. Not to be confused by the red insulation on my crimp lug. Right, Now for the controller, I've got a bit of a story here. When I got myself a Reflow oven, I managed to pick one up very cheaply from someone who was upgrading, and the oven had a fault, which was pretty easy to trace. It was simply one of the solid state relays had died, so I just need to replace that, and I've got a good working Reflow oven now. But it came with a Controlio 2 controller, which I'd sort of decided I'd like to upgrade that since I got the oven for almost nothing. I thought I'll spend a little bit of money and buy the upgraded Controlio 3 controller and swap it all over. So that left me with a spare Controlio 2. So I'm going to hook that up and give that a try on the preheater for Reflow. Right, so to do that, Controlio 2 comes with screw terminals. We've got our 5 volt DC input, which says requires 1 amp, so I'm good for that. We've got the thermocouple input here, and we've got common positive 4 inputs here for the element relays. So we'll only be using one of those, of course, so I'll just use D4. So let's get those hooked up. And we'll check we've got 5 volts coming out, so that's good. Okay, power connected. So our thermocouple, get that connected. And lastly we have our solid state relay. So the middle terminal is the common positive. Let's wire the positive up. And the negative side I will wire to D4 output. Right, we should be all connected. I might just redo that positive. I'm very happy with the way that's sitting. Let's just give that a twist and fold it over. And put them back in. Yeah. Right, now turn all this over. Okay, let's apply power and see what we've got. And we have Controlio 2. Let's just double check the voltage. Sure that'll be fine. Okay, 4.95 volts, that's fine. And it's currently measuring the temperature at around 22 degrees Celsius, which would be about room temperature at the moment. Setup. Okay, D4 is bottom, D5 is unused, D6 is unused, D7 is cooling fan, not really, don't have a cooling fan. Max temperature 215 degrees C, that'll be fine for my lead-based solder paste. Door servo. Well, we don't have one of those connected, so bake temperature, so we could set the temperature on this if we wanted to just heat it up and maintain it at a certain temperature. Oven is in learning mode, that's what we want. Okay, give this a try. So learning mode, let's just say yes to start reflow and see how we go. Settings changed, initializing. Learning mode is enabled. That's what we want to see. Pre-soak. The LED 4 has come on, that's indicating output 4 is enabled. Yep, I can feel that heating up. Okay, it's done the reflow cycle now. Okay, it's reached temperature, so it's now doing a 40-second reflow. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, and then it beeps. So if I was reflowing a board now, the beep would be when I need to remove the board off the top, because there obviously is no active cooling. No door to open. So the LEDs are off, so basically this is now just cooling itself down. Okay, so my preheater is now fully reassembled with the Control 2 controller attached to the front. So it's made a really nice compact finish unit. So I thought just to do one final test, I'll fire it up and reflow a little test board. Let's just put this over here for a moment. I'm actually doing a project with some STM8 microcontrollers, so I just need a breadboard, one of those. So I thought I'll grab one of these little 20-pin dip adapters. And get myself some solder paste. I could just manually solder this, but since we want to give the preheater a shot, let's use some solder paste and reflow it. A thin line of paste across there. Grab my tweezers. Drop that on there. My mains power. Just turn this around. Turn it on. Okay, pre-soak 48 degrees, 60 degrees, 80 degrees, 100 degrees, 150 degrees. And soak phase, 165. You can see the flux activating. Now into reflow, ramping up, 180 degrees, 185 degrees, 190. You can see the solder is just starting to go off and reflow. See how many solder bridges I create. 30-second countdown for the reflow. Okay, time to remove the board. Reflow over, so that was all automatic. I just basically had to push the start button, wait for the beep to indicate the reflow was completed, and then remove the board. Right, for a quick demonstration, I've got a PCB here with 5 surface mount resistors and a SOC23 transistor, and I've got my camera here pointing at the display, which I'll just turn on, so you can see the progress. Start reflow, yes. Okay, we're on pre-soak. And the temperature's starting to go up, 30 degrees. Soak. And reflow. Just getting to the melting temperature, 181 degrees, 183. And you can see the paste just going off now. And we're on the 40-second countdown. So I'll just slide this board off, drop it on my silicone mat, and I'm going to switch her off. That's it. Thanks for watching.